सीधा पढ़ा है ना नॉर्मल
Okay.
पढ़ाई.
So we have the list, the districts over here on the top and the salesman on the left side. So the districts are A, then B, C, D, and E. And the number of salesmen are for A it's 32, B 38, then C is 40, D 28, E 40. Then we have for two second salesman for second part. The second salesman is sells 40 products in district A, 24 in B, 28 in C, 21 in D, and 36. Similarly, we have 41 for the third salesman, 27, then we have 33, we have 30, 37, right? Then we have 22, 38, 41, 36, and again 36. This is the fourth salesman because district 5. And then we have 29, the fifth one, 33, 40, 35, and 39. Now we'll that was the marketing manager has 5 salesmen, and so now we need to find the we need to find ये दब गया सर, ये वाला दब गया गलती से.
अच्छा क्या हुआ सर?
पॉज कर दो एक बार सर.
ये
चलिए आप समझ
वो वाइट एप्स में नहीं लिखा रहता था ना.
हाँ
वाइट एप्स में तो नहीं लिखा रहता था.
इसीलिए तो सर को ये बोला दिया. मुझे मैं जानता ऐसा प्रॉब्लम होगा.
we need to find the assignment of salesmen to districts that would result in maximum sales. See there are 5 districts, and what is our aim? Our basic what is being asked is that we need to find the districts that would result in the maximum sales, that would result in maximum sales. So we can do it like this. Since it is a maximization problem, convert the profit matrix into opportunity loss matrix. So convert the profit matrix into opportunity loss matrix into opportunity loss matrix. By subtracting all the elements by from the highest element. You see the highest element here is 41. There is no element which is higher than 41 in total group. Okay, so you can write like this: highest element is 41. Okay, let's go ahead and form the table. Okay, if you subtract 32 from 41 from 32, you get 9, right? Then you get 3, subtract it was 38, so 41 minus 38 is 3, then 41 minus 40 is 1, then it's 13 for your 28, and again 1 for, and these are A, B, C. These are the assignment model being made now. Now 1, 17, 13, 25, 0, 14, 4, 19, 3, 0, 5, 5, and then you have 12, 8, 1, 6 and 2. Now go ahead. Now to reduce the matrix, so that now
नहीं ऐसा कुछ बोले नहीं, मैं ध्यान भी नहीं दिया।
reduce the matrix so that there is at least one zero, so that there is at least one zero in each row and each column. That is the rule. There is one row, 1 0, 1 0 in at least one row and one column result is table 2. This is your result. Then you grade the table 2, give the this is your table 1, and that's your table 2. Result is table 2. Let's make the table 2 so that we can make at least one zero in each row and each column. So if you can see like this, we have 8 here, 0 0 7 0, then you have 0 here. Go ahead subtracting, okay, we will get 0 12 and then 14 4. So we have 1 0 in this row and 3 zeros in the first row. We will come to this again, this column 0, then 12 over here, 8 6 4, then you have 19, we have 1, we have 0, we have 0, then 5, 11 5, so 0 here, 0 again in the table 2 again, and then 1. So at least 1 0 and 1 in one row and 1 0 in one column we have. So now let's find the number of cross rows. This is how you cross it. This is how you can cross it. So now number of crossed lines, you can see it's 4 equal to 4 greater than 5. Therefore not optimum solution. Therefore not optimum solution. Okay, so again you can go ahead to find an optimal solution by drawing this table. You have A, you have B, C, D and E. 1 2 3 4 and 5. That's the end, you know, that will give you the solution right now. 12, then you have 0 here and 1, then you have this, it goes like this, 7, this 0, and that's where you are going to 1 1. That becomes your assignment model now. Then you have 0 like this, 8 4 2, and then you have 0, and that's your second last. 23 1, 0 is your 4, that's your 5, 15 5, and 1, and that's become your solution. सर अभी देखो सेव कर कैसे हम करेंगे अब ये, अब मैंने प्रॉब्लम तो ये हमने दबाया, ओके अच्छा,